So this video is another video for chain rule. It covers the notes that we did in class. We're just going to work back through this. So in class, we said to derive a composite function, we're going to do the derivative of the outer function times the derivative of the inside function. And we never change the inside function when we're doing this unless we're applying an identity. So if we have f of g of x, a composition of functions, the derivative is f prime of g of x times g prime of x, derivative of the outside times the derivative of the inside. We're going to start with guided practice 3, and all we're doing is repeatedly applying the chain rule in different contexts. So for number 1, we have 4x cubed plus 3x minus 2 to the 5th. So f prime of x is, the outside thing is something raised to the 5th power. So its derivative is 5 times that something raised to the 4th power. And then we have to multiply by the derivative of the thing that was raised to the power. So the derivative of 4x cubed is 12x squared, and the derivative of 3x is 3. This is going to be fully simplified. If we wanted to distribute 5, we could, but that's unnecessary. For example, 2, we have this problem where we could do the quotient rule, but it is easier to rewrite this as 3 times 4x minus 1 to the negative 2 power. And from there, we multiply the negative 2 times the 3, we get negative 6 times 4x minus 1 to the negative 3 power. And the chain rule says that we should also multiply by the derivative of 4x minus 1, which is 4. So we get negative 24 times 4x minus 1 to the negative 3. If we wanted to fully simplify this, it would be negative 24 over 4x minus 1 cubed. For example 3, we have this cosine of 4x minus 1. So our outside function is cosine, and the inside function is 4x minus 1. So we're going to have a derivative of, so the derivative of cosine is negative sine. And remember, we never change the input for the chain rule. So negative sine 4x minus 1. And then we also have to multiply by the derivative of 4x minus 1, which is 4. So if we simplify, we get negative 4 sine 4x minus 1. So a way to think about this is whatever you see in the original problem, you have to have a derivative for that thing. We have to have a derivative of cosine. That's the negative sine 4x minus 1. We also have to have a derivative of 4x minus 1. That's 4. If it's not in the original problem, you don't have to find this derivative, because sometimes there are going to be some things that hang out at the end that look as if we could continue to take derivatives. But if it's not in the original, don't do its derivative. So for example, 4, we have f of x equals sine squared of 3x. That's the same as if we have the sine of the quantity 3x, and we just put the 2 on the outside. So building off of what I said about taking the derivative of everything in the original problem, we have 3 things that exist inside this original problem. We have something squared, we have a sine, and we have a 3x. So that means we need to take the derivative of the thing that's squared, we need to take the derivative of sine, and we also need to have the derivative of 3x. So the first thing we do is we take the derivative of the thing that's squared. That's going to be the sine 3x. So we get 2 times the sine of 3x to the first power. Next, we have to multiply by the derivative of sine, which is cosine 3x. But then we also need to multiply by the derivative of 3x, which is 3. So fully simplified, we get 6 sine 3x cosine 3x. So again, anything that exists in the original problem is going to be in the derivative, and they will all be multiplied. No product rule or anything. It's not sine times 3x or anything like that. So we had three different things that require derivatives: a squared thing, a sine, and the 3x. Jumping over example 5 and 6, let's move down to this table where we have h of x equals x times f of x plus g of 2x minus 5. We would have h prime of x equals, to do this first term, we have to do the product rule. So that's going to be x times f prime of x plus, let's see, f of x times the derivative of x, which is just 1. We'll just put the 1, plus the derivative of g of 2x minus 5 is g prime of 2x minus 5 multiplied by the derivative of the inside, which is 2. So do we need to simplify? No, we don't. So to calculate h prime of 3, that is going to equal 3 times f prime of 3 plus f of 3 plus g prime of 2 times 3 is 6 minus 5 is 1. So g prime of 1 times 2. So this equals f prime of 3 is 4 times 3 is 12 plus f of 3 is negative 4. And g prime of 1 is negative 2. So plus negative 2 times 2 is another negative 4. So 12 minus 8 is 4. So this is going to conclude the video over us going back over the chain rule. If you still have questions, watch the other video I did over the chain rule where we work problems from the text, and it's just the chain rule. And eventually we apply the product and quotient rule as necessary. If you still have questions, come see me or talk to me before or after school. Thanks.